Lattice energy is the energy required to separate an ionic compound into its cations and anions. So whenever we think of an ionic compound, we know that the term ionic simply means that we're going to have two separate elements or molecules that exist in a cationic and anionic state that are going to come together to form a compound. And the lattice energy specifically talks about the energy needed to break apart that ionic compound to get those cations and anions. For example, when we have NaCl, the energy required to break this ionic compound into Na plus and Cl minus is referred to as lattice energy. So the energy required to separate the cations and anions is called lattice energy. Now, when we want to calculate lattice energy, it's simply the charge of the cation multiplied by the charge of the anion divided by the bond distance. So if we were to take a look at this example of NaCl splitting into Na plus and Cl minus, we have a +1 charge here and a -1 charge here. So essentially we would go +1 times -1 and we'll simply get still 1. And we're going to divide that by the bond distance. Now, to make bond distance simpler in some questions, if you're not given the bond distance can be correlated to size. So we know that if we look at a periodic table, size increases going down this way. So size increases going down and to the left of the periodic table. That means that francium is going to be our largest element, whereas helium is going to be our smallest element. So as we go this way, the size is increasing, so our bond distance is also going to increase. Now, if we take a look at this example, we're given these two molecules and we want to figure out which one is more difficult to break. So the more difficult to break an ionic compound into its cations and anions corresponds to a larger lattice energy. So essentially, we have to determine the lattice energy of both of these molecules, and whichever one has the higher lattice energy is going to be more difficult to break. Now, we know lattice energy is going to be the charge of the cation multiplied by the charge of the anion. So for this molecule, we're just going to go 2 times 2 divided by the bond distance. And we'll get to the bond distance in a second. But over here for this second molecule, the lattice energy is going to be equal to 3, the charge of the cation multiplied by the charge of the anion divided by some bond distance. Now, what's important to note over here in this question is that the bond over here, the bond distance here and the bond distance here, they're exactly the same. So that means that we're not really concerned with our bond distance. We're concerned more with the charges. So if the bond distance is the same, let's just say the bond distance is 1, for example, and that means we can replace this with 1 down here and 1 down here. So this first molecule will have a lattice energy of 4, whereas the second molecule will have a lattice energy of 9. So since this molecule has the higher lattice energy, it's going to be more difficult to break compared to this molecule, which only had a lattice energy of 4. So once again, what we did was we looked at the charge of the cation, we multiply it by the charge of the anion. We can see that in our equation over here. And we divided by the bond distance. The bond distance was the same in both of the questions, so we just represented that as 1. You don't even have to put the 1 because you know bond distance is the same, so you're just going to focus on the charges and figure out which charges are producing that larger value. So in this question, this molecule is going to be more difficult to break because it has that higher lattice energy. Now, taking a look at this question, we've switched roles. We have 2 molecules and they both have the same charge and they differ in their bond distance, and the question is asking which is easier to break. Now, if a molecule is easier to break, that means it must have a smaller lattice energy. So we have to find the lattice energy of both of these molecules and determine the lower lattice energy. So once again, lattice energy is equal to the charge of the cation multiplied by the charge of the anion divided by some bond distance. Now, for this molecule, it was simply 2 times 2. And for the second molecule, it's going to be the same thing. It's going to be charge of the cation, charge of the anion divided by some bond distance. Now, you can quickly note that the bond distance is very different between these two molecules. Molecule A over here clearly has a larger bond distance compared to molecule 1 over here, molecule 2. So if you have a larger bond distance, you have a larger value in the denominator. A larger value in the denominator is going to produce a more smaller value. Let's say that molecule A, it looks almost 3 times bigger than this molecule over here, right? So let's just say that molecule A is 3 times bigger. So whatever the bond distance is, it's 3 times bigger compared to molecule B. So if we break it down, let's just get rid of the bond distance. And here we'll put a 1 because this one is going to be 3 times bigger. This is going to give us a lattice energy of 4 divided by 3, whereas the lattice energy here is going to be 4 over 1, which is simply 4. This value is obviously greater than this value over here because this value is going to give us 1 point something. So that means that this molecule A is going to be easier to break because it has that smaller lattice energy. In this question, it's important to remember that we were looking at the bond distance. Bond distance is in the denominator, so if you have a larger value in the denominator, you're going to get a smaller value overall. And that is essentially a quick overview of lattice energy. In another video, we'll go into more detail about more complex questions.